We're going to switch our general topic from flash flood forecasting to winter weather applications, and specifically use of satellite imagery and products to assist in diagnosing and predicting blowing snow and ground blizzards. And so we've got a great interactive session with Carl Jones from Grand Forks and Andrew Ansorge from Des Moines. I just met Carl this morning. I know several people from Grand Forks, but we just had the privilege of meeting this morning. Andrew, on the other hand, was the second person hired for the original OPG staff. He was a research associate with us for a couple of years and then went to New Orleans and is now a forecaster in Des Moines. Without any further ado, I'll turn it over to Carl and Andrew.
All right, thank you, Kim, and I want to say thank you to everyone who showed up and allowing me to share this awesome imagery from GO16. We didn't really expect to see this until it unfolded in itself, and we're really excited to share with you some of the things that at least some of the Northern Plains offices have kind of utilized some imagery from GO16 to view blowing snow. And there will be a quiz at the end, so you better be listening. All right, so we'll go ahead and just start by, I guess, kind of sharing with you the story and the imagery of when WFO Grand Forks first noticed a blowing snow signature on GO16. So Matt, if we can go to the AWIPS imagery, we'll just jump right on in. So this was January 11th, 2018. And right now we are looking at eastern North Dakota, which is right here, and then into northwestern Minnesota. And as you can see, we had a system come through, and it dropped a little bit of snow, so we did have some blowable snow around. It wasn't entirely that much, but we were well within our North Dakota winter season, so there was plenty of snow on the ground. The antecedent conditions were kind of there, ripe for blowing snow to occur. And this is the imagery that we started to see during that day. Oh, and I should say that we did have blizzard warnings pretty much for a good portion of our CWA, and it encompassed basically the counties in eastern North Dakota, and as well as the counties just on the other side of the border. And then this area is known as the Red River Valley. There's a little valley that goes from north to south, and then we can pop over to the high-res topographic, and then just to kind of get an idea as to what our topography looks like, because it does influence how our blowing snow kind of goes. So you can see the valley right here that straddles the border between North Dakota and Minnesota. And you can kind of see the lowest elevation is here in the northern valley, and then it gradually kind of pencils into the southern valley and goes further up, and then on either side there is higher elevation. And for, at least in our neck of the woods, this is a significant elevation change, even though if you were here on the ground, it just looks like it's flat and plain. But this particular topography happens to have some influence on the winds, and in particular locally increases the winds. And time again we have just higher than expected winds within the Red River Valley. And as you can see, Matt's going from left to right. Just within a couple of counties, it changes at around from 800 feet to I think it's like 1,200 feet or even more. So yeah, it's around 800 foot difference between the lower portion of the valley and then just outside of the valley. So then we'll go back to the satellite imagery. And I guess a couple comments on the satellite imagery. This RGB that we're looking at is a local favorite, at least within our office. This is the day snow fog RGB, and it will be featured within this presentation pretty extensively as we kind of go along. And so as the event unfolded, we happened to see these higher clouds start to move out to the east. This is with that synoptic system that was responsible for dropping some snow over our area. And then we happened to notice some other cloud signatures streaming from north to south. And we thought, that's kind of interesting. Is that cloud that we're seeing And then, we poked our heads outside, and we can still see the sunshine. Sometimes we're still able to see some blue sky, and we realized that this is blowing snow, and was like, oh my goodness, we were actually seeing this blizzard on satellite imagery. This, in this case, is what we kind of refer to as a ground blizzard, and that's you have your reduction in visibility due to blowing snow without actually any snow falling. So we were able to quickly utilize this imagery as it became apparent to us relatively immediately, and it helped refine our blizzard warnings to maybe just kind of right here where the visibility reductions were most, maybe a little bit further down to the southern portions. But we were able to get these counties out here in eastern North Dakota and get rid of the blizzard warnings there. And so to kind of talk a little bit about the thermodynamic environment within this type of blowing snow setup, we'll go to the RAP analysis and at point J. That'll be right here within the blowing snow plume itself. Grand Forks office is also not an upper air office, so we kind of have to use these RAP analysis just to kind of give an idea as to what thermodynamically and maybe even more importantly, what the wind profile looks like. So we'll load that. And sometimes when wind planes can come in and out of, say, Fargo or Grand Forks Airport, we can use the AMDAR data that comes out of that as well. And once we start looking at this sounding, we're going to really focus in on the lowest kilometer of the profile. So we are at 16Z or so, and you can see right there at the lowest kilometer, you have a pretty sharp inversion, say above around 500 meters, but really at that first 500 meter point, you can see there are steep lapse rates within that point that is helping to harness the higher winds aloft. The highest winds aren't really that far off the ground, but there are higher winds, and your winds do increase with height. And so you're able to help transfer those winds down to the surface, because blowing snow, and in particular visibility reductions to blowing snow, it's a ground hazard. So you're able to utilize this wind aloft and transfer it down, and it really just shows as to how tall, I guess, these plumes can be, or how rather shallow the boundary layer really is. And this is after a cold front has really gone through, and you're getting some really good cold air advection, so you're maintaining those steeper lapse rates within the first half kilometer or so. And then with the winds within that layer, you can notice either by looking at the wind barbs or even at the hodograph, you are unidirectional within that layer. So you're helping organize the blowing snow into some horizontal rolls. And then we will actually kind of look into that a little bit further in the next slide of the PowerPoint slide. Mm-hmm. Yes. So this actually happens to be a different case. This was actually 4 days later where we had the same signature pop up, and we still had visibility reductions due to blowing snow, and some of them were pretty significant, a little more significant than we were expecting. And we happened to get lucky with one of those high-resolution satellite passes. I know it says Sentinel-2, but actually this is from Landsat 8. It's the same composite wavelengths that we put to make this false color imagery. And so since it is the Landsat 8, it's not technically 10 meter, it's 15 meter, and now it's a little more coarse. But one of the things that you could really take out of this is how organized these blowing snow plumes really are, and how tightly compact they are. There's a little bit of a scale right here. This is around 5 miles, and you can see just how short in width these blowing snow plumes are. We've heard from observations and experienced ourselves that you could have really terrible conditions, and then just a few minutes later, things start to clear up, and you can see that blue sky, and then 5 minutes later, really terrible conditions again. And what we're kind of thinking is that this, each one of these horizontal convective rolls are kind of moving, over a particular point, and so underneath those plumes, you're getting the true visibility reductions. So I thought it was just kind of interesting how we could, see what this looks like. And it's a little bit, I guess, important to see just how small and compact these plumes can be, because in previous generation of GOES, the coarser spatial resolution really smoothed out these signatures. And while the GOES 16 spatial resolution is just, it's a kilometer, it does do some smoothing, although you can see some texture with our blowing snow plumes, particularly at the lower sun angles as you start to get towards the afternoon, towards sunset. And so this was a very curious case to us. We were wondering why we were able to see this blowing snow plume, particularly why is it showing up a different color within the day snow fog RGB compared to what's snow on the ground? If it's all snow, shouldn't it all show up as the same color? Well, it wasn't, and so we had an email string kind of go through, and kind of the running hypothesis that really stuck out in my mind came from Dr. Steve Miller from Colorado State, and he mentioned that there was, this could be a result in the near-infrared band, that it was becoming more reflective in that near-infrared band because you have a higher population of smaller crystal sizes aloft and at the top of that layer. So you might be getting, more reflective kind of components just because of the suspension of those blowing snow crystals, those very, very small blowing snow crystals. All right, and with that, I guess we can go ahead and open it up to some questions, if there are any.
One question has, two questions have come up on Slido. Have you seen any correlation between the colors and values for blowing snow in the RGB to the visibility observed at the surface?
So with the visibility at the surface, we've been able to detect this blowing snow plume signature on a wide variety of visibility reductions. We've seen these signatures show up, I guess, for instance, right here at KBAC, this is Valley City. You can still see that signature show up a little bit, and you're only getting a reduction in 8 statute miles. Compared to just this neighborhood over in Fargo, it's like 1 1/4. And while it's on the edge of the actual main plume itself, you can still see that there are some blowing snow streaks within this entire area. So to answer, I guess, the question is that we haven't really seen a change in color, so to speak, at least not that I've been truly aware. And it might be seasonally dependent just because of temperature has an influence within this RGB, and we'll kind of get into that coming up. And we're still kind of unsure as to exactly why we're able to see this blowing snow so well within the near infrared. So maybe it has a difference in concentration of these blowing snow plumes that might lead to maybe very subtle color changes, but it's not very obvious at the moment.
So primarily it's visually the density and texture of the feature itself that's your clue.
Correct.
Okay, have you ever tried to order mesos for these blowing snow events?
Yes, we have. And Andrew will actually have a case where his office did get a mesosector over his area for one of these cases, and there has been multiple instances where we've ordered mesos for particularly this blowing snow cases, because it can become quite convective in nature, so you have things kind of develop a little bit more short fuse as opposed to what we're normally thinking of wintertime as long fused. So yes, we have.
Okay, another question was whether the visibility underneath the bands was lower. I think you answered that, and the observations support that. How about the Landsat imagery shows some regular spacing? Can you relate that to wind speed, and can that inform timing on forecasting?
It's possible. With the Landsat, you only get the one pass, one lucky pass if it happens to fall over during the actual event. Haven't really explored which wind speeds might go ahead and have an influence on how compact these plumes can be. Sometimes it can be pretty well spatially spread apart. In this particular case, they were very condensed next to each other. But say, for instance, down here, they're probably a little bit more spatially, spread apart as opposed to where we actually were getting our blizzard-type conditions.
Okay, next question, have the blowing snow plumes verified blizzard warnings? You can't really use that to verify them, but I suppose the question really is there correlation with webcams, ground visibility, readings, et cetera?
Yeah, so that's, again, where we will be definitely going over this using other observational data to help supplement our satellite imagery and help just complete our understanding as to what exactly is going on at the surface.
Okay, and one more. Do the bands extend north into Canada, and is there a connection to the lakes there, or are they iced over at this time?
Well, let's find out. So they do extend into the lakes. At this point, the lakes were iced over. This is January in Manitoba. And you can kind of see that maybe there is some sort of influence of the fetch going along those lakes. It kind of does seem like it's orientated pretty parallel to the longer fetch coming straight out. I believe that's Lake Winnipeg. And so it kind of goes through. It's still, the debate is up in the air as to how much snow is actually being advected into one area, or if it's just gathering all along this particular area, and then the further downstream it goes, the higher the concentration of blowing snow crystals gets, and then that might kind of lead to further reductions in visibility.
Okay, Dan Lindsay, you have a question.
Yeah, sorry, am I supposed to type the questions into Slido as well?
Well, I guess ideally, but it's fine.
Sorry, I missed that earlier, I apologize. I'll do that from now on. But since I have the mic, I wanted to understand the RGB a little bit better, because I'm not familiar with this one. So is the recipe at the bottom, the R and the G and the B?
Correct.
Is that, okay.
Correct.
So the red areas in principle are clear sky, and normally, is that true?
Yeah, so the red areas would be from the veggie band. It's kind of more or less like a visible band. You're getting a high output because the albedo is very high, and it's just basically snow. And then you're getting very low output from the near infrared as well as the brightness temperature difference products in that blue component.
So the blue then are clouds, and then the blowing snow that you're pointing out is sort of a slight variation, textured variation off of the red.
Correct.
In color.
Correct, and we think that there's actually, and we'll explore this, I believe, in the next block when we kind of break apart this RGB down and explore each of the components that we'll kind of see as to which channels or which components of this RGB is really adding the value to this RGB.
Thank you.
Okay, good discussion. Let's go on to block 2.
Yeah, so in this block, we will go ahead and break down the day snow fog RGB into its 3 components. This particular, approach, I believe is pretty good when you're trying to assess what exactly you're seeing within an RGB. You have an RGB in one of the 4 panels, and then 3 of its components in the other 3, panels. And to really diagnose what added value within each of these channels you're getting into the RGB. I like to look at a gray to white scale, or just a black to white scale. So the whiter the colors are, the more added value you're actually getting into an RGB. So might be something to kind of think of if you're just trying to figure out what exactly you're looking at in an RGB.
So if we want to, we could go to the supplemental slides, and we could kind of go over, kind of completing the picture while we wait for the AWIPS imagery to load here. So let's see here. So Carl talked about, I think we had a question too. Can you verify these plumes as a ground blizzard? Well, the satellite data kind of gives you a really good idea of the aerial extent of the blowing snow area, but it really comes down to looking at other assets such as DOT webcams. Many states have these. Obviously, this is a stationary cam. And you can assess based on going into like Google Earth. You can figure out how far apart these the telephone poles are there in the picture, and you can kind of gauge maybe visibility that way. You can also go use social media reports. Obviously, becoming more common for people to send things in via Facebook, Twitter. You can also go to like SnapMap and be able to kind of see what conditions are also like that way. So this was during the event we'll show here in the AWIPS imagery. The top one there is from north central Iowa in the morning hours, and then you go east of Des Moines. The right image is from Newton area. And so you can kind of get an idea of what this is doing to people on the ground. How is it impacting transportation at the time? And the other thing that's becoming more common are state DOTs are getting plow cams, so they're putting cameras inside their plows, and then you can see all these different imageries all over your state or your forecast area. And so this is one from Iowa, and we'll look at this because I've not seen what this looks like, but in the foreground or in the background there you can kind of see a plume. We're looking south in late afternoon, about 3 o'clock, and the wind should be roughly from right to left, kind of from the northwest to southeast is the wind direction. And so we'll kind of look at that here in a little bit once we get into the AWIPS imagery. So Matt, if you want to go back, and then Carl can kind of break down here, I think, the different components of the RGB.
All right, so yeah, here is an example of kind of that breakdown of the day snow fog RGB. Here in the top left, we have the actual RGB itself. In the top right, we have the red component, and that is channel 3, or that veggie band, set to a black to white scale. At the bottom left, we have the near infrared band, that 1.61 channel 5, or what's known as the snow ice band. And then at the bottom right, we have the, I guess it's labeled as the day fog product, and it's just a simple difference product between the shortwave infrared minus the long-wave infrared, or the 3.9 minus the 10.3. And again, each 3 of these components are set to the black to white scale, and they are also set ranges to what is associated within the actual RGB themselves. So if we go ahead and right-click on the day snow fog RGB and then go to the composite ranges, the composite options. And you can kind of see the red component goes from 0 to 100, the 1.61, that green component, 0 to 70, and then lastly from 0 to 30 on the blue component. So they kind of, they should match up well as to what kind of added value you're actually seeing. So we can go ahead and cancel that. So initially, I guess we're looking at northern Iowa into southern Minnesota, and you can kind of see this textured streak appearance starting in around northern Minnesota and extending down into the northeastern portion of Iowa. And also take note that we have a little bit in east or western Iowa. It's a little bit brown, or I guess gray. We're still seeing that textured streaks over it, but this is denoting an area where there isn't snow on the ground. The snow on the ground is going to be red, and then in this particular area it's not. But we are still getting some sort of streak-like components over that area. So we'll start with the veggie band, and you can see that it does have the streak-like components in there. However, they are just a little bit harder to see exactly where they are. Everything is more or less in a whitish gray kind of look, and that makes sense because it's the snow on the ground and aloft has a high albedo, and then so you're getting about the same reflective values coming off of that. And then if we kind of jump down to the 1.61 micron, you can see a little bit better definition of those blowing snow plumes. It's not really quite showing up black as you would expect from an actual, I guess, like it is with snow on the ground, an actual like ice phase. We are still getting a little bit of higher reflectivity, that higher reflective component again. We're thinking this is why we're able to see the blowing snow so well is because of this particular channel right here, something that wasn't on any of the legacy GOES systems, but they have been on other polar orbiting satellites. However, the temporal resolution that we now have with the GOES really makes it useful for us to monitor in real time and use operationally. And then lastly, in the blue component, the day fog product, you can see it within that plume that it is a little bit, there's some sort of difference, and there's still some questions as to why we're still seeing that there, if it has something to do with phase change or if it's particle size or concentration within these plumes. And then also, if you kind of notice down in western Iowa, that you can still see these little bit of brighter pixels, and they're very similar to what is shown here in southern Wisconsin, those brighter pixels. And then if you translate that to the RGB, you can see that this is matching up where it's picking up for that stratus component and where there actually might be clouds forming. And it is kind of interesting to see you're having this, I guess, maybe more cloud development over areas where there isn't snow, as opposed to where we are getting these blowing snow signatures and streaks.
Carl, do you want to show maybe how we adjust the RGB here?
Oh, yes.
And if you want, Matt, can you pull the day snow fog full screen and then do pull a new tab down so we can kind of compare and contrast? Sure. So pull the day snow fog RGB full screen. And now pull down the other tab up there, just kind of split the window. Perfect.
So what we're going to do is we're going to do a lot what Bill had shown in his presentations, that we're going to tweak the ranges within the RGB to help bring out the blowing snow signature just a little bit more in these areas of low light. Since we have two components within this RGB that has reflective components, we can get, I guess, more bang for your reflective buck as you start to get to that low light. And that's particularly useful in the higher latitudes where you don't have a lot of daylight to help bring out, the reflective signatures. So Matt, if we can go right-click on the left day snow fog RGB and go to the composite options. So for the red component, since it does have a reflective aspect to it, we can bring that down to, say, 50. And that's just going to bring out, make everything a little bit more red where there is areas of snow and high albedo. And then the green component, bring that to 30-ish. And you can really start to see that come out, each one of those bands. And that's because we really help squeeze that 1.61 micron range. And then you can bring down the blue just a little bit, maybe 25, nothing too crazy. But if we kind of have a side-by-side comparison of the day snow fog with it after we squeezed the range in this part, and then what it did look like, you can see that these almost greenish mustard kind of colored signatures really show up just a lot better. And then you're still able to use this RGB to monitor these blowing snow plumes just a little bit further into the day.
And the other thing, Bill in his talk talked about the day cloud phase distinction. So if we can turn that on the right panel there and just kind of show it a little bit. Day cloud phase distinction does an okay job of picking it up as well, but it seems to pop really a little bit more in the day snow fog. And we kind of talked about that, and it seems like maybe that red band, the 10.3 micron band, you're getting maybe, depending on the air mass that's coming in, because these are oftentimes when we get these ground blizzards, it's after an Arctic front's gone through, and so you're bringing in a much colder, drier air mass, And so you may be saturating that red channel so it doesn't show up maybe quite as well as the in the day snow fog. Is there anything else you want to add? I think that's all we have for this block, Kim. Questions?
Okay, there's a question, is there any correlation with the radar presentation or the JPSS VIIRS imagery, afternoon pass?
Yes, so for the radar, I'm not sure if we have that data loaded just to pull up on the fly. Yeah, that's fine. Yeah, that's okay.
Can you hold on, though, before loading the next case? Can you hold on before loading the next case? Okay, perfect.
Yeah, so for the radar, since these plumes aren't very tall, the radar will typically overshoot these plumes unless it's going right over the radar. And they basically look like low reflective, just streaks very close to the radar. We sampled heights with the radar beam kind of on average, definitely under 1 kilometer. And it really, we think, just depends on how thick this shallow boundary layer really is. Sometimes you can have blowing snow develop because you're with more or less daytime heating, extending your boundary layer up into that higher winds to help translate it down. But more often is the case where you'll actually have cold temperature advection really help drive those lowest level lapse rates and help reinforce it to help transfer that wind down to the surface. So they're typically pretty shallow. And as far as the VIIRS imagery as that goes, it does show up. And again, the near infrared band and even the spatial resolution of these polar orbiting satellites has always been there. So this particular case, observing blowing snow from satellites isn't anything new. But what is new is how operationally useful we can now make this, just because you have that added temporal component as well as the added spectral and spatial resolution.
So do either of you have a strategy for detecting blowing snow bands at night?
I do not. That
No.
would be definitely an area of interest. And I know one of the beauty, I guess, about with all of these bands is that you can make your own RGB recipe. And I think Kevin Hayek from the Duluth office did a pretty good job at tracking tracking smoke at night. Something that, as transparent as smoke, it'd be really hard to kind of understand, wow, can we really track smoke at night? So I think there's still some room for future work and just kind of playing around and trying to come up with a recipe like that.
Okay, there's another question here. In general, are other forecasters in your offices, comfortable with adjusting the composite options? And there was another question related, which was, if so, do you do it on the fly, or do you, sort of save it as a special bundle in an AWIPS procedure?
So at least for my office, I've tried to teach my fellow forecasters to kind of do it on the fly, just to get used to right-clicking, going to the composite options, or even if you're just looking at one image by itself, is to go to its ranges and then try to lower it just a little bit to see how much you can get. That's still, I guess, I want to say probably a work in progress to really get people comfortable with it. But we do have that option of editing these types of things. And if you kind of have that RGB approach where you break down its components into the 4-panel, I think that might make it a little bit more easy for people to experiment around and actually understand what they're doing to the RGB instead of just going all willy-nilly, just changing these slider bars without really understanding what's going on.
And at Des Moines, I don't think it's something we've really been doing. I know when Bill and I were first talking about this presentation on a mid-shift, he kind of brought it up. And so I've been playing with this in West because we have the case I'll be showing in Block 3. So I've been learning it. I don't think it's something we're doing extensively in our talk. And one thing, Kim, before we go to the question, Matt, can you, on the AOPS imagery, go to a lat long for me? I can get that to you once you turn on the readout. And go to 42.69. This is going to be in northeast Iowa. 42.69, and then 91.81. Should be. 81. So keep going west. Yeah, 42.69. It's a little further north. So that's going to be the approximate location of where Matt's cursor's at, is where that DOT cloud cam's at. So if we can maybe zoom in on that point too. And so you can kind of see what that band, you can see what it looks like here from space, obviously from the satellite. And then, so you can see a very narrow band. So where that cloud's at, probably if we had a rear-facing cam, you'd see the blowing snow plume to the north of it. And so if you just want to pop back real quick, Matt, into the PowerPoint just to show that, pop back into the PowerPoint supplemental slides, just so we can see what it looks like back there. So again, what Carl was showing with that Landsat pass is just this, visibility reduction changes greatly over such a short distance. They might have just come out of this band and down the road 1-2 miles, you have another blowing snow band coming across. So quite the visibility reduction.
Yeah,
Back to
that's a
questions.
good image to illustrate also why radar is often ineffective.
Yeah, you
pretty-
can see how
it's a
you got
couple
blue
hundred
sky
feet.
above that. It's probably,
Yeah.
as Carl said, maybe a couple hundred meters tall.
Two demonstrations of manually adjusting for low light conditions. Is there anything in the works to create color curves that change with daylight conditions? I mean, I think it's sort of so subjective that I suppose you could create some that, as a good starting point, but it may or may not reduce or eliminate the need to do adjustments as well.
I think that's right. I mean, I think there's just so many different situations of things you may want to highlight. I think there was a question you asked Kim from the Slido about, do we say these as procedures or bundles? I don't. Do you, Carl?
I do not. It's usually on the fly.
I mean, you could potentially, if you said like in your naming of the procedure, maybe like Alt RGB for blowing snow, that way you know what you did to it. But I think changing on the fly is probably the preferred method.
And, thinking about just the different time of year, let's say if it was early winter season, you're going to have, or late season, you're going to have more sunlight, so maybe this won't be as useful for as long. And then you're going to have to eventually, change back to your display once you actually do have more sunlight to help with your reflective components. So I think the fastest approach is probably just to adjust the color curves and the composite ranges yourself.
Yeah, I was just going to add one thing to that, Kim. It's a challenging thing to try and do, and one piece of information from the satellite that we don't have in AWIPS that would help achieve what was being talked about in that question is the solar zenith angle information, and we don't currently have that in AWIPS. I know some of the products that Sport makes or Sierra makes, makes extensive use of the solar zenith angle, and we could do a lot more with our RGBs in AWIPS if we have that information. I don't know where we stand on getting that.
So one other question was, have you developed, either or both of you developed West cases that could be shared to sort of expand the reach of these techniques for other offices?
That's a project I'll have to complete before the fall.
Okay, very good. And let's look at this one. How often have you observed blowing snow at the surface with no corresponding signal from satellite?
So there is actually one particular case that stood out in my mind, and that was during the 2018 season. We were getting some visibility reductions. It wasn't very much, and then it was really hard to find these blowing snow signatures. It was almost kind of considered like a null case for this particular technique. And what we kind of thought is that this is maybe picking up more of like the drifting snow. Maybe those plumes weren't as vertically extended as some of these other cases. But yeah, to answer it short is yes, we've seen it, but it's usually we see these signatures in a wide variety of visibility reductions.
Okay, and one final, I'll skip this next one unless you have something to speak to about it, because based on your earlier answer about a nighttime strategy, I assume nighttime microphysics has not been found to be useful. If that's not true, then speak to that. So the other question is 2-kilometer IR horizontal resolution on GOES-R sufficient to resolve these small bands?
So you can kind of see it, I guess, especially, I guess in one of these next cases, we can pop in just the IR band and then look at night to see if we can see these signatures. I want to say that it's shown up a little bit, but not to the extent where I think it's very useful. You really get your money's worth out of that 1.61 band to that near infrared band, which has a little bit higher spatial resolution.
Okay. We'll address these other questions later. Let's move on to block 2, or block 3, I guess it is.
So for this block, we'll be focusing on an event on February 14th of this year. It was mostly extended all the way up into the Grand River, or the Red River Valley of the North, up into Carl's home office of Grand Forks. We're going to be kind of focusing on northern Iowa as we were monitoring things. So setting it up, 2 days prior on February 12th, we had a fairly significant blowing snow event across our forecast area. It was a ground blizzard event, and one of our forecasters who's been there about 15 years commented that it was probably the most significant ground blizzard event they could recall in recent memory. So, it kind of gives you an idea of the magnitude of the event. And the questions going into this next event on the 14th was, had the snowpack stabilized across the forecast area, just from the blowing snow event prior to this upcoming event? And so that was what the forecast discussion the day before talked about. We were expecting another cold front coming through with strong gusty winds behind it, exceeding 30 miles per hour. And so, but there was concern that the snow might be in a storage state. But if you did get blowing snow, you're going to probably have significant travel impacts given the amount of snow cover that was on the ground as well as the winds expected. And then the following morning, this is about 6 hours before the event would begin, they were still anticipating blowing snow, but we were gaining warm air ahead of the front. And southeast Iowa was into like the low 40s. Des Moines was, I think, mid 30s. And far northern Iowa, I don't think got above freezing that morning, but still there's questions about how far this blowing snow might come because of the, you've stabilized the snowpack, you might have had some melting and refreezing that might have further helped to stabilize it. So let's go into the AWIPS imagery now, Matt, if we can. So we'll start off here. This is at 11 o'clock, and let's loop the right panel there. And actually, we can get rid of the split there, too. So you can pull that right tab, just you can exit out if you want. The right tab, the day snow fog alone. Yep, just close it, that's fine. And so the top left is going to be your visible 0.64 band, top right's your snow ice band, bottom right's your day snow fog, and then bottom left's the day cloud phase distinction. So first, Matt, if you want, can you pull up the Viz full screen and then kind of move up towards, southwest Minnesota, northwest Iowa. Southwest Minnesota and northwest Iowa, kind of move up into that area. And so kind of looking at the scene here, you can see there's obviously a lot of clouds moving across the, from west to east roughly. There's also across the Iowa and Nebraska border, there's some areas of other additional clouds that are kind of moving more south-southeastward. And then if you can continue to zoom in a little bit further up into that southwest Minnesota and northwest Iowa area, in this area generally, if you can zoom in a little bit further there, you can kind of see, especially with the visible band being at a half kilometer, you can kind of get an idea of these little streaks. And let's stop on the last frame too, because I don't know how this is buffering for the folks out there watching at offices. You can kind of get these very subtle bands that are almost a little bit darker areas that are kind of oriented about 350 to, say 170. And let's loop it again, and you'll be able to see kind of overall just the motion moving from north to south through that area. And if we go to the next band, the snow ice channel, it doesn't show up as well here. Obviously, you're now at a kilometer resolution, but there's still kind of a hint, maybe if you're really subtly looking forward, there's kind of a grayish, just slightly grayish coloring that's kind of drifting from south, or from north to south. And as we go to the next one, which should be the day snow fog, RHB, this again is where you can see some of these things in the base imagery, but it really comes down to when you start getting these RGBs generated that you can really pull out additional detail. And here it just pops out a little bit more of these kind of north to south bands that are almost blackish or maybe a dark purple here. Yeah, perfect, Matt. Thanks for stopping there. Especially in the far northwest Iowa counties there where Matt's circling, you kind of have these north to south bands. So we obviously can see that we're getting this kind of signature, but what is it exactly? So let's throw on the METARs, which should be loaded down there. And we can loop it again once those come on. As we let this load here, you can look up into southwest Minnesota, even into far eastern South Dakota. Your visibility reductions down to 1.5 miles, half mile there, 1.25 here. As it comes down to northern Iowa, you can see like Esterville here, which we'll show some other ground imagery from. They're from 3 down to 3.25 of a mile. And then like Sheldon here, it goes from 4 to 3 miles. So you're definitely seeing some reduction from this blowing zone that's coming into the area. So let's skip ahead now, Matt, if you want to adjust the timeout to kind of, let's look at the, do we have the other procedure here, the 1-minute imagery? So at 16Z, there was a mesoscale request that went in. That was a question we had in the first block. Yes, you can request mesoscale sectors for this, and certainly do. You don't, obviously during the winter cold season, you don't have as many competing mesoscale requests, generally for like convective or tropical. The priorities for those generally are going to be, depending on if you have any headlines out, blizzard warning, winter storm warnings are 13 priority, winter weather advisories are 21, and if you don't have anything, you can always go for the general 23 priority. I guess if you have a high impact event or you're having equipment issues like Bill's office has sometimes, you can maybe put in a priority 5 request for radar outage. We can look at this time, it's fine. So yeah, go back and again up to that kind of that northwest Iowa, probably just generally northwest Iowa, far southwest Minnesota there. And the nice thing, with the 5-minute imagery is obviously much higher temporal resolution than what we had in the previous GOES constellation. But now with the 1-minute imagery, I mean, it's just kind of a very fluid drifting of those bands from north to south. So again, the same orientation as what we saw before. Let's go back to the day snow fog map and look at that. I'll pull that up as a single image. Well, this works. Again, you can get this kind of similar sense. When Carl was showing in block 2, you kind of get that mustard kind of looking. You kind of have it here a little bit. Again, what Matt was talking about with the zenith angle, you're getting closer to midday, so maybe the angle of the sun is more direct on the surface, so you're not maybe getting the shadow or a little bit of a shadow that you might have gotten with the blowing snow plume earlier in the day. So let's also on this one, Matt, let's go ahead and do the composite options, right-click and hold on to the day snow fog, and we'll try to adjust the RGB, kind of looking at what would it look like if we tried to do the kind of the compressing the color curve. So change that one down to, I think, what is it, 50. And then change the green down to and then, about 30 actually. Let's go back up a little bit. About 30. And you can adjust the green or blue down a little bit. Just a tad, yeah. So you kind of pull out a little bit more there.
Maybe even adjusting the red back up a little bit more.
Sure.
And see if it brings it out. It's subtle, but it's there.
And that's the thing, I think, with adjusting these RGBs, depending on the time of day, you may not get the bang for the buck. But I think, like Carl was saying in block 2, when you get into these low light, high altitude, or high latitude cases, that's where it can really help out being able to pull it out a little bit further. And so let's jump out one more time let's go out to, I think, 21Z. If you can set the time for that, that'll be kind of the same low light situation where we can show the RGB adjustment again. 21Z, yeah. And then we should just be able to loop it back an hour, and that should be sufficient. And once you do get it up, Matt, we can just go day snow fog again, pull that up full. That's fine. This time now, the blowing snow bands kind of continue to progress, but we're also getting the high clouds moving in overhead. So kind of as Carl's alluded to, for ground blizzards, you're kind of limited. You need clear skies above, otherwise you're not going to be able to see the signature. And so if we can also put on the METARs here, Matt, as well, that'd be helpful. So you can see where it's extending back up here into South Dakota. And, all these high clouds are coming over. As we'll see with the visibility reductions, the quarter mile here at Spencer, 3/4 down at Storm Lake. Even though the clouds are going over, you're still getting this blowing snow continuing, obviously. It's not stopping because the clouds are moving over the top of it. It's just that you're not able to see it. And so, if we can, Matt, let's do the composite adjustment here if we haven't already. I don't think it held. Did it hold?
I think it did.
Okay. Well, if it did, then we can. Yeah, it did. Okay. So cancel here, and then I would just do the same thing we did it in earlier where we create a new tab and then pull it down to the right side just to kind of show the compare and contrasting of the adjustment.
And while we kind of wait and load, you can kind of, if you're looking at the actual ASOS or the METAR visibilities, say for instance, here in Sioux Falls, they're reporting around 2.5 to 3. They're still getting those signatures kind of move right on over. Same with this METAR right here. It looks, at least the color of the actual blowing snow plumes, there might be some subtle difference, but maybe not that much. I think there was a question if there is an actual color difference to help gauge what the visibility restriction or reduction is going to be. And I would say it's probably more on the no spectrum, but that is an area where you could really hone in and maybe do some more research.
Yeah, I kind of agree with that. I mean, with these bands being so narrow, you might have a band that goes over the airport that's kind of continues to go over the same airport, but your visibility either side of that could be much different, much more improved. So again, here Matt's zooming in kind of on the same area. You can see that in just the general and the default color curve on the right, you can see the bands pretty well still. I mean, there's kind of the darkness to them, but then when you adjust the color curve as we've done on the left, that whole area just pops out as kind of that mustard yellow coloring. So now if we can go to the supplemental slides now. So just kind of looking at what happened on the ground. This is a webcam I pointed out Estherville there in northwest Iowa. This is throughout the day with the conditions that were going on. So you can see at times, going down to whiteout conditions when a band would go over and then would improve, obviously as those bands maybe moved off to the east. And then plow cam imagery. This is one that's just west of Estherville, and then we're going to kind of go along the track of it from say 9:30 to about 11:15. So here it's in town. This is kind of before the winds really picked up. And then as it does pick up, you can start to see in the distance, visibility is starting to become more reduced. You're losing more of the horizon as we go with time. The bands maybe moved a little bit further east now, so you've cleared out a little bit. And as they continue to go along, visibility just changes depending on where they're at. Now they're in a sheltered area. So again, you can see out in the distance the haziness of the blowing snow, but in the sheltered area, it doesn't look too bad at all. And again, now we're in a different spot. Maybe they're plowing a little bit of snow too. Visibility is much more reduced. Again, you can see the streaks going across the road here. So as far as messaging, what we did with kind of the imagery, we put out some social media posts about the blowing snow with one of the DOT plow cams. One thing we could do, kind of what Ariel Cohn's done with, I know when he was at Topeka, he showed at this workshop kind of a nowcast graphic of showing the satellite imagery. I don't remember exact details of that, but I think he had shown like orphan anvils, so the environment was becoming more conducive for, thunderstorms. He kind of did like a nowcast. You could certainly put in some GOES imagery to kind of show, especially like Carl's area, where maybe if you have a band of blowing snow coming down from Canada, you can kind of show that this is going to be moving into our area and expect visibility reduction this afternoon. And so then we were also collaborating with our northern neighbors to figure out what we were going to have out. We didn't have a headline out when we came in on shift that morning. And so phone calls were made, and we were able to collaborate with our neighboring offices to kind of work on putting out additional winter weather headlines. So this is a wind chill advisory here in the light blue, and then we extended the winter weather advisory down into southwest Minnesota, into north central Iowa, and it was later expanded in the afternoon. Obviously with the GOES imagery, there's a lot of different ways you could use this to provide DSS. We get state emails about, accidents that are going on in the state. This was one of the impacts on this day. This was a jackknife semi northwest of Des Moines. And there's another shot of it from about 5 minutes later. So you can provide this to the DOT, especially if it's maybe before the event hits. 2 years ago when we had the big pileup on I-35 near Ames, you probably have seen the video of all the cars colliding into each other near Ames. We had that morning in Des Moines, we had a truck fire, a hazmat situation that closed down the interstate before the snow moved in. So if you saw like an area of blowing snow, which was not the case in this situation, but if you saw that area of blowing snow, you could certainly reach out to your partners, Iowa State Patrol, Iowa DOT, and let them know. It might be fine right now as you're working this hazmat situation, but very soon you're going to see significant visibility reductions. So I think we'll end with that at Block 3.
The first, somebody from one of the remote locations said, shout out to Matt Foster for running AWIP so well during these talks.
My wife
So,
must be in Sligo.
well So, okay, Andrew, the DOT camera snapshots are fantastic for real-time verification. Did you have to ask them for permission to post to social media graphics, or is that sort of an ongoing agreement, or what?
Yeah, we'll usually credit them, but yeah, they don't have any problem with us posting things. I know later on in this event, they actually sent out a tweet, I think a little after we issued the winter weather advisory, and they shared basically one of their plow cams and kind of heightening awareness, and we can retweet their tweet. So.
Okay, the next one for both of you, I mean, I think you've sort of alluded to this already, that they asked how many cases you've observed this, and obviously there have been multiple cases, and typically you do sort of tweak the composite options to bring out features, right? So here's the next one. For challenge of nighttime, could you use daytime GOES information to better correlate to model info and then see where the model may have info for overnight? I'm not sure what model info you would use for this particular feature, but you can speak to that.
I guess I could see if you maybe use the HER or wrap visibility, you could kind of look at it that way. Maybe that's the model data you could be looking at. I guess, if it's correlating well in the late afternoon as you're kind of seeing the last images of GOES, and you kind of see that the HER or wrap or whatever model you're looking at is correlating well with the visibility, you could kind of use that, I guess, as a proxy, as we don't have anything at the current time that seems to work real well for nighttime blowing snow.
Okay, are there other WFOs who have observed blowing snow events? So I guess WFOs who are dialed in, chime in. I don't know, maybe you guys know if your neighbors also use these techniques.
So typically, you have to have this kind of ground blizzard type scenario to really utilize this imagery. So it's mostly confined to the northern plains or the upper Midwest, but there was one in particular instance that happened earlier this year, the January 29th polar air outbreak, that these signatures just lit up over basically from the Dakotas all the way down to Iowa and even into northern Illinois and Indiana. That was really interesting to see because we were curious ourselves as to, is this good for a lot of offices, or maybe this is just a local thing? We have heard, ground blizzards being an issue over in Wyoming and areas like that where they have the higher plains, but still kind of like a very flat and plateaued. Yeah, and that's where I'll stop right there.
Okay, I'm going to go to the second one first because Matt can start working on this. Can you load the .64 viz and then alter the range, increase the mid and decrease the max to try and bring out that signal? So while you're working on that, fellas, have you ever followed up on these blowing snow events to see how the snowpack might be redistributed for snow water equivalent accounting?
Carl, do you want to talk about that? We were talking about that last night.
Yeah, so one of the more interesting things that I've been a part of is was working with NASA and then University of New Hampshire. We were trying to verify satellite observed SWE data from the SSMI, particularly in the Red River Valley. And one of the signals that showed up that was kind of perplexing to us was a depression in SWE values on the western edge of the valley. So we were wondering why this was showing up if the entire area was more or less the same snowpack. And even we had some co-ops kind of reporting when they reported the SWE values, more or less the same. So we went to the higher resolution Sentinel-2 data and looked at this, and we started to notice that we were starting to see a little bit more bare ground in that portion of the valley, and we were, it kind of signaled to us that the snow was being scoured away from this entire area and moved into a different portion of the valley. So it was lowering the SWE values. And ultimately, when we actually did have our spring flood, that area didn't receive as much flooding within the western portion of the valley. So yes, we have seen it. You have to kind of use some other satellite and other observational tools, but
Okay, interesting, thanks. So do you want to speak to what you just did, Matt?
Yeah. Excuse me. So I did what was suggested in the Slido question there, and I compressed the min and max a little bit. And oh wait, the right hand pane is time matched to the METARs, which is not useful.
Is your mic on, Matt?
Yeah, it is.
Okay, great.
I just need to get a little closer to it. So I did what was suggested there, and I think I brought the max down to about 80 or 85 or so, because obviously the scene isn't terribly bright, so those upper ranges aren't that useful. The lower ranges are, so I only brought the min up to I think 5 or 8 or something, and I think maybe that does enhance the contrast a little bit if you're just looking solely at the 0.64, and I'll let Carl and Andrew speak to that now.
I would agree. I mean, it might even help. I'm thinking maybe midday might help to pull it out a little bit more. I'm not sure. I've never looked at that, trying to adjust that.
yeah, and just for the actual visible imagery, we're probably noticing it being pulled out just a little bit more, as you mentioned, the higher contrast, because you're starting to get a little bit more shadow as the sun angle goes down, and it's casting, these plumes are casting shadows upon themselves just to the east, downed zenith angle, I guess. And so maybe it's kind of midday when your zenith is a little more parallel to the orientation of these plumes, or it might not be as useful, or maybe these plumes are growing during the day, and then maybe that's why we're starting to see more casting of a shadow. But I think in this particular case, just by using the visible imagery alone, you're able to see that, just because it's a result of the actual bright blowing snow plumes coupled with their own shadows right next to it.
Okay, we've covered the Slido questions. We have a couple more minutes. Are there any questions from the room? Yeah, go ahead. You have to press and hold the microphone, but go ahead.
Yeah, hi. Mike Jamalkowski. I work with Aerospace Corporation. But I spent a couple of years up at Grand Forks stationed there in the Air Force, probably before you were born. But the locals had an interesting term for the blowing snow. They called it snert. I don't know if you've heard that.
Yes, yeah.
And so I'm wondering what role do other components besides the ice crystals play in your ability to monitor and maybe forecast that phenomena?
Yeah, it's very possible that you could have some mixture of the dirt and snow within these plumes, and maybe that has some sort of microphysical impact on what we're actually seeing within the plumes themselves and satellites. So it's very possible. We'll need to go out there and probably catch some of the particles as these snow plumes are advecting along to really verify if that would be something. But yeah.
Yeah, you don't have to go very far because the blowing snow infiltrates your house every crack it comes in the dirt.
Yes.
Okay, anybody else? All right, let's move on to the next block.
All right, so block 4, I did mention there will be a quiz. So right now we are going to have you play the role as a forecaster. We're going to provide 2 different scenarios where we're going to have an EM call in and ask for more or less a forecast. We're going to provide you with the satellite imagery, and then on the next scenario, we're going to provide you with the satellite imagery as well as the some supplemental data that might help you complete the picture. So this first particular instance, if we can go ahead and put on the interstates. We're back up into the Red River Valley, and actually before I go there, we're actually going to utilize the Slido poll, and then for those who are watching remotely can participate as well, and then maybe pick out what you might say to this EM. So the scenario is going to be, you got a call, you're on shift, and you got a call from an EM, and he needs to get a route forecast along an interstate from the international border, this is I-29, of Canada, all the way down to Fargo. And if you want to take a minute or so, maybe discuss amongst your neighbors to kind of come up with, let's go ahead and turn off those ASOS, because there's an ASOS outage. Sorry.
More equipment issues.
Yeah. So just using satellite imagery alone, what could you maybe provide this EM along, just kind of, you could even just talk about the visibility reductions from the Canadian border all the way down to Fargo based on the concepts that we've kind of taught.
And the Slido question says I-94, but it is I-29, the north to south interstate there along the North Dakota-Minnesota border.
And Matt, we could also maybe squeeze the range on this composite as well, since we are getting close to that sunset time frame. So yeah, collaborate with your neighbors within your office, and maybe come up with a quick forecast. Yeah, that'll probably work. Yeah, so Grand Forks is right here, but we're interested from the international border down to Fargo. This is Grand Forks. Up here is Grafton.
Fargo's KFAR there.
Yeah.
So Matt's circling Grand Forks right now. And so make sure as you guys discuss amongst yourselves to go into Slido, and then there's different 5 different answers there that you can provide the EM. Provide them with the best forecast you can just off of solely satellite data.
And while people are discussing, maybe we can toggle on the topography as well. Just kind of briefly show them. Maybe topography might have an influence as to what's happening at the surface. I guess we can just toggle back and forth from the blowing snow and the actual topography itself. Okay, yeah. Yeah. It's good. Good time. How much else is there? 11:50. Okay. Maybe just about one more minute or so.
If you could, Matt, just stop in the last frame in case if there's any sort of buffering issues on the YouTube feed.
All right. So wrap up your discussions, and if you want to provide your forecast to this EM on the phone, just go ahead, at least for the people here in the audience, if you want to go ahead and raise your hand and can let you speak on what you might say or what you think the visibility might be along this route.
So the discussion in our little subgroup is underneath the clouds on the northern part, we can't really see, but looking upstream, it looks like it's probably very bad blowing snow, so reduced visibility. South of Grand Forks, there appears to still be some of that texture, but slightly less. So we were thinking none of the above, and the answer would be blowing snow the whole way, but worse north of Grand Forks.
Okay. All right, very good, very good. Anybody else have something different, or is that pretty much the consensus?
No one wanted to vote for my answer of what blowing snow, clear conditions?
I agree. I agree with Dan.
Okay. Yeah, and so from the poll, it looks like, expect blowing snow along the entire route with extremely reduced visibility, i.e. a quarter mile or less, all the way down from the Canadian border down to Fargo. That seemed to be the most popular answer. So if we can go ahead and turn on the ASOS visibility, and we can actually kind of see what might be happening. Is that maybe what you were expecting? So right up in here in the Northern Valley, we had visibility reductions of around, I would say 1 to 2 or maybe 3 miles, and then further down, once you get to Grafton, it gets a little bit better. Grand Forks in this particular case didn't really get a whole lot of visibility reductions, and then even more so down in Fargo. However, like you had mentioned, if you look up upstream of this blowing snow plume, this particular site was stayed quarter mile basically throughout the entire day. Probably could have gone for just a one county verified blizzard warning. But one of the things that we were trying to figure out as to why we weren't seeing visibility reductions within the valley, even though we're still seeing this signature pretty much for a good portion of our CWA. I think the answer might have lied within the topography. If you see the orientation of the blowing snow moving from northwest to southeast, this higher elevation outside of the valley was getting that visibility reductions. And once it got into the valley, maybe those plumes were completely skipping over and they were just elevated, missing these areas. And then it was even more interesting is that when it went to the other side of the valley and ramped back up in elevation, you started to get those reductions in visibility again. And in this particular case, there were notes from other forecasters coming in that day. I was like, wow, you could really see these really low-hanging clouds streaming pretty quickly just above the office. So that I thought was really interesting how topography might have played a role in this. And while we kind of, I don't want to say really misled, but it was just kind of to bring out the point that, you can't just use this satellite imagery alone. You still have to get some verification, look at your other data sources as to what's happening on the ground, whether it be the ASOS or some supplemental data like the plow cams or the DOT cams or social media to kind of help really complete that picture because we want to know what's happening at the ground. So I guess we can go to the next scenario. And this next scenario, we're going to be looking at this same case. We can leave the ASOS on, but now you get a call from maybe that same EM and something is happening in northeastern North Dakota, where he needs to send an air medevac up there, and he's limited to, he can't send his planes or helicopter to an area where there is significantly reduced visibility. And so he gave us 3 distinctive locations where there could be potential landing sites for this medevac. And that's what's in these points that labeled A here next to Munich, and then B in eastern Cavalier County, and then C, and then in northern Grand Forks County. So with that in mind, these are our landing sites that could be potential. And I guess the answer that we want to provide with him is which location is going to see the least reduction in visibility. And then with this in mind, we can go to Matt, the supplemental slide, and this is going to give you some images, and I guess we'll go to the very beginning. I guess I can do that. Sorry about that. Wrong one. This is going to give you what you might have seen on social media, or you got an email from the DOT. And so this is kind of highlighting areas as to what's happening at the surface. So now you have in your mind what had happened on satellite. Now you can go ahead and complete the picture by looking at these additional webcams and ground verification.
So I think we could probably start the polling feature, Amy, if we could, for this one, if you have that available. Yeah, so kind of like Carl was saying, complete the picture. You got the satellite imagery there in the background. The pluses are the 3 landing sites. The top left one would be A. The kind of the top right one, that's A, that's Matt circling. And then the other one to the east of that would be B. And then the farthest south one is point C.
So again, maybe discuss among yourselves and see if which particular site has the least, and we'll even say which site has the most reduction in visibility. And again, the northwest site, or Munich, is this particular site where Matt is highlighting. And then the southeast of Cavalier site is just to the east of that. That's that site. And then the Grand Forks County, the southern site, is right here for those attending.
And Carl,
remotely.
it's kind of hard to see here, maybe with the surface observations. What's the nearest visibility to each of those landing sites, A, B, and C?
Okay. Yeah, so with the Munich site, right here at Langdon is a 1/4 mile, and then, yeah, we can do that. I'm sure everybody, maybe we can toggle back and forth. So that point A, that Munich site, is a 1/4 mile, and then just to the southwest of it is reading at 9 miles. So there seems to be quite the gradient between where this site is. And then point B, that southeast of Cavalier, to the northwest of it, there's 8-mile visibility, and then just to the northeast of it is 1 3/4 miles. And then the Grand Forks County site is just to the north of it is 6-mile visibility, and then Grand Forks proper is at 5-mile visibility.
And we'll give everyone about a minute to get your answers in before we close the poll.
All right, anybody want to take or provide an answer as to which site you think would be, have the least amount of visibility reduction? So which site has the best visibility?
Well, I don't think I'm going out on a limb to say it probably will be B. And the reason I say that is in the photos from the snowplow cams, it was the one with no snow streaks across the road. And also, if you look upstream there, it looks like it's starting to clear up beyond the cloud mass. Yes.
So right in this area?
Yeah.
Okay. All right, did anybody else have a different answer? And I guess which site might have had the most reduction in visibility, do you think? Yeah, maybe this site. It's pretty obvious that you have, with Langdon getting that same amount of reduction in visibility within this area of blowing snow, and with that blowing snow signature still right on top of it, you probably are still getting the same amount of visibility reductions despite this site can do reporting 9 miles, but you're just not getting that that blowing snow signature on top of it.
And we're talking about the top left point there for people watching on the YouTube stream too.
So, yeah, there could be a differing, differing arguments between the other 2 points. Like you had mentioned, you utilize the DOT cam to try to help complete that picture within that site. And then you had mentioned what was going on upstream, which is pretty good, and not being fooled by seeing just this stratus cloud and being like, oh, well, there's no blowing snow here. Well, there actually is still probably some visibility, some blowing snow advecting in underneath that stratus cloud. So it's very possible that that could be a viable location. And I would even argue that point C is also another viable location, at least that has least amount of visibility reductions, despite upstream where it does have that quarter-mile visibility. Again, with that topography influence, you could be completely missing that blowing snow to reach the surface, at least this point right here, because that's right on the edge of the valley. It's still in that lower elevation. And then here at point B, kind of when the elevation starts to increase, at least right over here, you start to see that visibility start to go down a little bit more. And it looks like B, southeast of Cavalier, won by a significant margin as for least amount of visibility reductions.
And one thing we're not taking into consideration here, I heard some people in the audience talking about, we have stratus in far northeast North Dakota there that might, depending on the pilot's qualifications, whether they can fly in that or not, as well as the strong wind gusts that are going on. We're just looking at visibility here.
All right, and with that, we will open up for questions if there are any.
Thanks for participating at home.
Yeah, great forecasting.
Yeah, it was a fun exercise. Thanks for adding that. If I don't have the slide. Oh, it looks like there are no new questions on Slido. Oh, can you sometimes detect blowing snow with radar? I think you spoke to that earlier, that typically it's too shallow.
Correct.
Yeah.
You'd have to have that blowing snow pretty much go right over the radar to actually start to see it.
With the February 14th case too, we had radar data too, and yeah, you don't see the blowing snow plumes. There was some horizontal convective roll-induced snow showers that you could see, but it wasn't the blowing snow.
So are there any questions for Carl and Andrew from the audience? All right, we'll close early. Oh, wait a minute. Here's one. Late entry from Sierra. Does your office use aviationweather.gov as a resource for forecasting?
Does yours?
Sure, I can answer. I mean, we'll look at it. I'm not sure what aspect you're talking about specifically. I mean, I know they have, obviously SIGMETs they can issue and things like that. I'm not sure if that's where they're going down exactly. For TAF purposes, I guess when I think locally, we certainly can utilize that if we need to, but on a day-to-day basis, we don't, at least in Des Moines, I don't think.
Yeah, I'd say we're pretty similar as well. I know some other forecasters use it a little bit more than others. I personally probably don't use it as much as I should, but I think I, find at least for METAR data and that kind of thing, usually just kind of do the overlay within AWIPS.
Okay, it was a really interesting application of satellite imagery to a very unique forecasting challenge. So thanks very much for your time. Let's give Andrew and Carl a hand.